Hello everyone, welcome to my channel. I'm Tijani Abagaro, a solution architect. In the previous video, I made Aws Vpc graphical design. On this video, I will create Aws Vpc by using Python. Once I create Aws Vpc, I will configure it. I will attach IGW, Internet Gateway. Then I will configure the subnet in multi-availability zone. Then I will launch EC2 instance, a virtual server. The configuration of security group in the NAC list, network access control list, is part of that. And then I will attach elastic load balancer. Okay, let us start coding. To start coding, in Python actually, we need to import Boto3. Boto3 is AWS SDK for Python. It is a nice library that fully integrated with AWS resources so that we can manipulate the resource, AWS resource, directly from the Python scripts. To be more clear about it, let me take you to the Boto3 documentation. Boto3 documentation. Boto3 is like this. That's it. Our main purpose is to create VPC. VPC is within EC2 client, within EC2. The boundary of EC2, it is here, VPC. Virtual private cloud, VPC is here. You know, in order to use Boto3, we need to import it. Here, import Boto3. Once we import Boto3, we need to tell Boto3 that the types of service we are using. Here, we are using EC2. EC2 service in order to create VPC. That's it. So, for every action, for every method we create in the script by using Python, we are going to import these things. We are going to import it. We are going to telling it what kind of service we are going to use. That will be tedious and monotonous. It is very redundant. So, to avoid redundancy, it had better to create a class. From that class, we will import that class into different classes or elsewhere and use it. So through that, we will avoid redundancy of these things. That will connect and that will tell the Boto3 what we are doing. All right. Okay. For that, let me check my system. Let us check Python. I'm using Python 3.9 here. All right, let me check AWS services. AWS, here, all the service we need in AWS can be accessible from the command line. So let me go back to IDE. On this one, let us create a connector class. Call it connector. use botos to create to use botos3 in Python, we need to import it, right? So import botos3. Once we import botos3, create class connector. Let us initialize it. It takes client as parameter. Self is there is a convention that every method takes self, all right? So we take a client as parameter here. Self dot client is equal to botos3 dot client, then it needs argument here. By the way, the attribute is equal to the actual value. So we are it is expecting an argument here. Client and the specific region on which we are going to connect to AWS. Let's say region name. These two arguments is equal to let us select or let us take any region we wanted to connect it to. For instance, use US East 1. US East 1 is Northern Virginia. That means in order to manipulate AWS resource from our script, we are using this one, and then we are going to connect it to US East 1. The specific region we selected here is US East 1. All right, let me show you on console. AWS console, aws.amazon.com, then sign in to the console. Oh, I'm already signed in. Automatically went through. All right, here, click here. What I wanted to say is US East 1 is here. US East 1 means Northern Virginia. Whenever we create, whenever we manipulate any resource on this from our script or from Python, we are going to connect to US East 1 or Northern Virginia. It doesn't go, we are not going to search our service from other in other region. There are multiple region here, as you can see. AWS Cloud has multiple region. We selected specific region here. Our region is Northern Virginia. That means we are going to create VPC in the Northern Virginia. All right. In order to return the value, we need one more. In order to call our class in other place, we need one more method that returns a value. If you can call it any name, let's say EC2. EC2 connector. Or EC2 client. Or any name, get EC2. Get EC2. So it has return value, return self dot client. That's it. You have done with class connector. So the next step is we need to tell botos3 that what kind of service we will use to manipulate AWS resource. So for that, we need to create another class. Call it EC2 client. Call it EC2 client. Then let us input connector class as parameter to inherit it. So we can inherit that, initialize it. And then let us use method override over here. So to do that, we need a super method. Initialize it. So it is expecting a client. As you can see here, it is expecting client as an argument. Our client here is what? EV2. All right. Now we can create VPC. To create VPC, we need to have VPC class. All right. Okay. Let us have a separate package. Name it EC2, and then create VPC. VPC. Name it VPC. Then class VPC. Class VPC. Let us initialize it. Initialize it. Input client as parameter here, and then self dot client is equal to client. The actual value is equal to the parameter is equal to the actual value. All right. To create VPC, we need create VPC method. Let me take you to both 3 documentation to be more clear about it. Here we are on this one. We're looking for create VPC, create on the client. On the client, we are looking for create VPC method. Here it is, create VPC method. This is create VPC method. This method takes a lot of this is create VPC. This is create VPC method. So in our case, I'm going to create the VPC within IPv4. So I will take Cedar block as input. There are multiple arguments here, including IPv6. All right. So let us back to our console ID and define create my VPC. Then this has a return value, return self dot client dot create VPC, the method we have seen on the bottom documentation. Then let us take Cedar block as an argument here. Block, as we can see, it is a string. Let us give IP range like this 10.0.0.0 /16. That's it. What does that mean? It means we are using CIDR block. That means we are using IPv4, IP version 4. IP version 4 totally has 32 bits. Now we are using 16 bit. Out of the 32 bit, we are using 16 bit for the network portion, and the rest 16 bits will be for host IP address. 32 bit in a 10th to the power of 32 IP address. To the power of 32 IP address means, unique IP address means, it is about 4 billion. There is 4 billion IP address. More than, yeah, it is 4 billion. 4 billion something. The device in the world has been using these IP addresses. But the number of device that has been connected to the internet is greater than 4 billion. We know that. Because in order to resolve the shortage of IPv4, there are some mechanisms like using NAT, network access translation, by creating a local area network. You will buy a few or one IP address, public IP address for one. Once you bought that, then you will have a local area network in your company so that multiple devices can communicate locally. And to connect to the internet, you will have NAT so that the whole company will use a single IP address to communicate to the internet by using a NAT. That is a concept of switching and routing. We can use also IPv6 here as argument if you wanted to create our VPC by using IP version 6. That is actually also a solution, to resolve the shortage of IP v4, because it is IPv6 is 128 bit, in a sense, to the power of 128 unique IP address. That means 3.4 times 10 to the power of 38 unique IP address. It is about 340 times trillions times trillion times trillion. Huge. So forget about the device that exists in the world. If we represent that IP with grass or with sand like that, can cover the surface of the earth. In our case, it is enough to have, since it is a demonstration purpose, even I can use less than this one, because I can use the CIDR block here can support the maximum 60 within the 16. The minimum is 28 bit. In this between, you can use anything you want for demonstration purpose. If you are applying VPC for your company, you need to have the proper calculation of your networking. All right. For this one, we are using to the power of 16. To the power of 16 is a lot. It is about 65,000 devices can be connected, can be used. More than 65,000 devices can be used within this VPC. All right. Okay. To run this VPC, to run the code we created, we need main method. Okay. Let us go and create the main method. Rather than calling here, let us have a separate place. Click here, name it generator. Then, by the way, to use those class VPC into the connector class, we need to import them from .ec2.vpc import VPC. Import EC2 client. That's it. So we need to have main method. So once we have this one, then we need to call EC2 client class. Then we need to call the method get EC2 method, so that we will connect to the resource. All right, EC2 client dot get EC2 method. Now let us call VPC. A concept of initialization instantiation work here. You know, VPC here expects a parameter, an argument client. So it is expecting this one. EC2 client dot get EC2. It is expecting. This looks like something complex. To avoid complexity, we can assign this with some value like EC2 connection, so that you can easily use it. So avoid this one from here, and the input EC2 connection. That's it. Also assign this one like with VPC, like this one. So it is good. So once we're done with this, what we need to call the VPC create method from the VPC class, like this: VPC dot create my VPC. Right, that's it. Also, let us assign this value with something like VPC outputs or VPC response. Now things looks great. Then what we need, let us run it. Okay, let us print the progress to see when the VPC will be created on the console. Say print like the VPC has been created. Then concatenate with a string like the output of that one. Create VPC is the output of that VPC response. That's it. So all right, let us run it. Let us run it. Come here, then run it. Yes, congratulations, we created VPC. So let us look at it. Let us look the IP address. Let us look with first. Let us look at VPC ID. This is VPC ID with VPC 0.505E77. This one is VPC ID. All right. Let us go. Let me show you on console. Go to console. We already have in here. Okay. VPC. One VPC is there. It is this one. Our VPC ID, as you can see, it is this one, right? It is VPC 05E77 to 10, like this. So here, VPC 05E77, this thing. All right. Okay, then. Let me rearrange this one to decorate or to use this thing elsewhere. Let me make like this. Let me make like, let us define one method here. Define generator. Generator. And then put the main method here. Main method here. Then call the generator under the main method. The same thing is true. Let us run it to be sure about it. Run. The same thing is true. Now we created another VPC. Okay, folks, subscribe for more videos. Thank you.